Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to design rectangular microstrip patch antenna edge feed with quarter wave transmission line at 2.4 GHz operating frequency. So in order to design any microstrip patch antenna, initially we have to consider three parameters that are operating frequency, height of the substrate and type of the substrate material. So now here I am considering the operating frequency is 2.4 GHz, 2.4 GHz and type of the substrate material is FR4 and its relative permittivity constant is 4.4 and height of the substrate is 1.6 mm. So using these basic parameters, first calculate the length and width of the patch antenna. So using online calculator, first calculate the length and width of the patch antenna and the dielectric constant is 4.4, height of the substrate is 1.6 mm and operating frequency is 2.4 GHz operating frequency. Select synthesize the length of the patch antenna is 29.4 mm and width of the patch antenna is 38.03 mm and input impedance that is input impedance is edge feed input impedance is 243 ohms and after that calculate the 50 ohm feed line length and width using my online microstrip line calculator. So now the dielectric constant is 4.4, height of the substrate is 1.6, operating frequency is 2.4 GHz, 50 ohm transmission line and electrical length and 50 ohm feeding line. The electrical length is 180. The electrical length is 180. And select the synthesize. So the width of the 50 ohm feeding is 3.05 mm and length is 34.24 mm. So now here and this is the 50 ohm feeding line and the width is 3.059 mm and length is 34.24 mm. So next calculate using online calculator lambda by 2 transformer quarter wave transformer length and width. So using online calculator. So now here the dielectric constant is 4.4, height is 1.6 mm, frequency is 2.4 GHz, 50 ohm and electrical length is 90. Select the synthesize. The width is 3.05 and length is 17.12. So the length is 17.12 mm and width is 0.35. So now the quarter wave transformer and that width I am considering approximately 3.059 by 4. Approximately we will get 0.76. So now here I will take that width of the quarter wave transformer is 0.723 and after that calculate the ground plane length and width, ground plane dimensions, length and width of the ground plane. And this 50 ohm transmission line length is 34.24 mm and this quarter wave transformer length is 17.12 mm. So adding these two values 34.24 plus 17.12 into 2 into 2 plus length of the patch antenna 29.4 mm. So the length of the ground plane is 132.16 mm and width of the ground plane is 2 times of the width of the patch antenna. So now the width of the patch antenna is 38.04 mm. 2 into 38.04 that ground plane length width is 76.06 mm. So these are the ground plane dimensions, patch antenna dimensions, and 50 ohm feeding line and quarter wave transformer line parameters. So now open ANSYS electronic desktop HFSS software. First save the project. Right click on the project, select save as and select your suitable location. So project name is rectangular microstrip patch antenna edge feed with quarter wave transformer. Click the save button. So project is successfully saved. So first to design, first to draw the ground plane. Select the rectangular sheet. Select rectangular sheet, draw the rectangular sheet in the plane. So give the rename rectangular one, double click on the rectangular one, rename is ground plane GND. Now change the dimensions of the ground plane. So the ground plane x size and x size width of the ground plane is 76.76 the width of the ground plane is 76.06 mm. So round figure I am considering 76 mm and length of the ground plane is 132.16 mm. So round figure I am considering 132 mm. And position. So the position is half value of the x size. Now the x size is 76 and half value is 76 by 2 before representing negative sign minus 76 by 2 comma y position is 0 and z position is minus 1.6. So press the OK button and z position is 0. Z position is 0. Select fit all. Select fit all. And this is the ground plane design. Next draw the substrate, select the box, draw the box in the plane. So give the rename of the box 1, double click on the box 1, substrate, and the type of the material is FR4, edit the material, FR4, epoxy, and change the dimensions of the substrate. So the dimensions of the substrate is same as that of the dimensions of the ground plane, and the ground x size is 76 mm and y size is 132 mm and height of the substrate is 1.6. Height of the substrate is 1.6 mm and portion is minus 76 by 2 of the x size before representing negative sign and y portion is 0 and z portion is 0. Press the OK button. and this is the ground plane, and this is the substrate. So on the top of the substrate we can design patch. Select the rectangular sheet, draw the rectangular sheet in the plane. So give the rename of the rectangle one. So this is patch. So now change the dimensions of the patch, and width of the patch is rectangular patch antenna width is 38.03 mm, and length of the patch is 29.44 mm. 29.44 mm. So width is 38.04 mm and length is 29.44 mm. And X position is half of the width value. Now the width is 38.03 divided by 2. So before representing into sign, that is the X position value, minus 38.03 by 2, and Y position is so adding the 50 ohm feeding line length and quarter wave transformer length 34.224 mm plus 17.12 mm, and which is 51.36 mm. 51.36 mm, that is the Y position, and Z position is 1.6 mm, and height of the substrate is 1.6 mm. On the top of the substrate, the rectangular patch antenna is designed. So height of the substrate is 1.6 mm. So now is the OK button. So this is the rectangular patch. And after that, draw the edge feed 50 ohm feeding line. Now select the rectangular sheet, draw the rectangular sheet in the plane. So give the rename of this rectangle one edge feed. Change the dimensions of the edge feed, and the length of the edge feed is 34.24 mm. Length of the edge feed is 34.24 mm and width is 3.059 mm. Axis is along Z axis, and X size is width of the 50 ohm feeding line is 3.059 mm, and Y size and length of the 50 ohm feeding line is 34.24, and position is X position is half of the X size before representing into sign, minus 3.059 by 2, comma Y position is 34.25 mm and Z position is 1.6. So Y size is minus 34.24 mm. And after that, draw the quarter wave transformer. Select the rectangular sheet, draw the rectangular sheet in the plane. So give the rename of this rectangular sheet, and this is quarter wave transformer. and change the dimensions of the quarter wave transformer. So quarter wave transformer, and this is along the z axis, and x size is width of the 50 ohm transmission line by 4 approximately. So that value is approximately I am considering here. So 0.723 mm, 0.723 mm, and y size, the length of the quarter wave transformer is 17.12 mm, minus 17.12 mm, and position and x position is half of the x size value before representing negative sign, minus 0.723 by 2, and y position is, and that y position is, and 34.24 plus 17.12, it is 51.36 mm, 51.36 mm, and z position is 1.6 mm. So press the OK button. And after that, unite, patch, 50 ohm feeding line and quarter wave transformer. So select patch, quarter wave transformer, select the patch antenna, edge feed and quarter wave transformer. Click on unite button. All are unity. So this is the design of the patch antenna on the top of the substrate, and 50 ohm feeding line and quarter wave transformer line on the top of the substrate. And after designing quarter wave transformer, assign perfect electric boundary, ground plane and patch antenna. So select the ground plane and patch antenna, assign perfect electric conductor boundary. So right click, go to assign boundary, select perfect E. So press the OK button. So the perfect electric boundary conditions perfectly assigned for ground plane and patch antenna. So this is the patch antenna and this is ground plane. And after assigning perfect electric boundary, assign the port, lumped port excitation. So that lumped port excitation is in another plane. Now we are the XY plane, and rotate this structure. Select, and this is Z axis and this is X axis, and this is X axis and this is Z axis. So selecting YZ plane, first select the YZ plane. So draw the rectangular sheet, in the plane. Sorry, and this is X axis and Z axis. Select XZ plane, not YZ plane. Select XZ plane, X axis, Z axis. Select XZ plane. So select the rectangular sheet. So draw the rectangular sheet in the plane and give the rename of this rectangle. This is the port. So now change the dimensions of the rectangular port. And X position is minus 1.5295, and Z position, Y position is this one, and jet position is 0, and that height is 0. Okay. And x size is width of the 50 ohm feeding line. The width of the 50 ohm feeding line is 3.059. 3.059, and axis is along y-axis, and jet size is minus 1.6. So press the OK button. Okay, now here height is jet portion is 1.6, that is the height of the substrate, and this is the port. Now assign lumped port excitation. Select the rectangular sheet, select the port, right click on the port, go to assign excitation, select lumped port. So draw the integration line from draw the new line integration from lower port to the upper port. Successfully defined. Press the OK button, and the impedance is 50 ohms. And this is lumped port excitation. And now coming back to the XY plane, select XY plane, select the fetal, properly arrange the structures, and after that assign radiation boundary. There are two ways we can assign the radiation boundary. One is the manual procedure. Select the box, assign, select the dimension, proper dimensions of the x size, y size, z size, x position, y position, z position. That is the one way. And another way is go to HFSS, modeler, create open region, create open region. So now the operating frequency is 2.4 GHz, and select the radiation, press the OK button. So this is the open region. So now change the type of the, now the material of the boundary is open region is vacuum. If you want to change the material, so double click on the radiating surface, go to the edit, and the type of the open region material is air material. And after that set the analysis setup, go to the HFSS, analysis setup, add solution setup, select advanced. So now the operating frequency is 2.4 GHz, and I am selecting the number of passes 12, and maximum delta S is 0.02. Press the OK button, and after that this window will appear, and sweep type is fast linear count, and the operating frequency is 2.4 GHz. I am selecting the starting frequency is 1 GHz, and ending frequency is 4 GHz, and select the maximum number of processor. Maximum number of count is 101. We want to observe now here the 1 GHz to 4 GHz. We can observe 101 samples. So press the OK button. Setup is analyze, and after that check the validity. Click on the validate or go to the HFSS. Press validation check. So the design is successfully validated, and now start the simulation. So go to the HFSS and press the analyze all, or here the press analyze all. So simulation, it will take some time depending upon our system specifications. So simulation is successfully completed, and after that observe the S parameter value. So go to the results, right click on the results, create model solution data report, select rectangular plot, select S parameter S11 in decibel, select the new report. So now select the operating frequency. So operating frequency is 2.4 GHz. Mark the operating frequency 2.4 GHz. So at 2.4 GHz, the return loss value is minus 3.35 decibel. So practically the return loss value should be less than minus 10 decibel. Now here the return loss value is minus 3.35 decibel. So the antenna is not designed properly. Slightly we can change the patch antenna dimensions, length and width of the patch antenna I will change. Now here I will change the patch antenna dimensions, length and width. So previously the patch antenna width is 38.03 mm. So now I am considering the width of the patch antenna is 38.9 mm and length is 28.5 mm. Select the OK button. So now check the design validity. So design is successfully validated. Next start the simulation. Select analyze all. So after completion of the simulation, the S parameter plot updated automatically. So simulation is completed. So now at 2.4 GHz operating frequency, the return loss value is minus 13.23 decibel. So this value is less than minus 10 decibel. So the rectangular microstrip patch antenna, edge feed with quarter wave transformer at 2.4 GHz operating frequency successfully designed. So next check the VSWR value. So go to the result, right click on the result, create model solution data report, select rectangular plot, VSWR. And now mark the operating frequency at 2.4 GHz. The VSWR value is 1.57. Next observe the radiation pattern, 2D radiation pattern and 3D polar plot. First select the, okay, now we are already radiation pattern is selected. So go to the results, right click on the results, create far fields report, select radiation pattern, select the again radiation pattern in decibel and select the family of the values are minus 90 degrees, 0 degrees, plus 90 degrees and select the new report. So now here the in geometry is 3D and its value is here in the 3D and phi value is minus 180 to plus 180 and theta value is 0 to 180. So now I will change the theta value 0 to 360. We can observe. So this is a two-dimensional gain radiation pattern. Minus 90 degrees, 0 degrees. Next observe the 3D polar plot. So right click on the results. Go to create far fields report. Select 3D polar plot. Select gain in decibel. Click on the new report. And select the directivity in decibel. And this is a three-dimensional directivity radiation plot, and its maximum value is 7.1 and gain value is 3.1. Next observe the 3D polar plot with the structure, and this is the structure. Observe the 3D polar plot with the structure. So right click on the field overlays, go to the plot fields, radiation field, select directivity plot 1 and set the transparency, apply. So this is the 3D polar plot with structure and different orientations. Top view, right view, front view.